said, so we have a lot of content today, so I'm going to try my best to squeeze as much as I can into our 20 minutes. But wanted to talk a lot about really how you can identify impacts to your CP system through interference studies, utilizing our products, and as well as some basic best practices across the board. So just a brief agenda. Again, it looks really small, but there's a lot of content here. I'm going to just give a brief introduction to influence and interference studies as a whole. We'll go through some methods and best practices for performing INI studies. I'm going to bounce around between INI and influence and interference today, just because INI rolls off the tongue a bit better. So we'll just be doing that. I do have a real world example as well. We performed a study several years ago, and so I have a real world example I'll talk about to show everything in action, and then kind of some conclusions and moving on into questions and answers for everybody. So just giving a brief overview of influence and interference studies, I'd be very curious to know how many people in the audience are very familiar already with influence and interference studies. This is a pretty common topic, especially nowadays. This has become more and more common, especially with crowded corridors and more when we have less land to lay down pipelines and more requirements to move product. So I know that there's a lot of more systems inside of crowded corridors. You're having to share systems sometimes. It gets challenging. So just again, a real brief introduction. A lot of people say that influence and interference studies kind of keep them in the same wheelhouses, and they're the same thing. Technically, yes, but they're also technically different. Just kind of a brief look at an influence study versus an interference study. These are really critical studies that operators use to determine the level of interference or influence, but they are different. So an influence study is really focused on the extent that a specific cathodic protection system impacts a structure or an area surrounding a structure. So this is much more focused on your CP system, maybe a specific rectifier in your system, a galvanic anode. How is that influencing the CP on your system? Versus an interference study is more dedicated to actually finding stray currents or focusing on other sources of electrical input that could disrupt your cathodic protection. So just kind of showing an example of this more on an influence study side. I have a waveform here from our FDC application. This is a waveform of a normal 3-on, 1-off interruption cycle, but this pipeline has a Dairyland PCR on it. So you can see at the bottom of that waveform, you're going to have some slight influence on your off whenever you perform an on-off study. So just again, these are some key points for the different, what goes into more of an influence study. It's really focused on, like I said, specific system impacts for your CP system. So these are things like your decouplers, your anodes, potentially bonds, and your own rectifiers. And if there are any power sources on your line that affect your own compliance. This is super helpful because engineers use this to really help understand the level of protection provided by your CP system, because this is performed with close interval surveys as well as periodic and annual surveys. So this is a very good look at how your assets and your power sources are interfering or influencing your CP. And this is also really beneficial to help identify where you might need to make adjustments if your CP isn't adequate in a certain area because of your own assets. Versus an interference study is much more focused on finding external sources of interference. So these are things like potentially a high voltage AC line or another operator's rectifier, other items that could affect your CP system. So I have an example, I have a waveform on the screen here from our field data collector application of a waveform that's been affected by a high voltage AC line. So it's a similar 3-on, 1-off item, but you'll see that waveform is a whole lot less crisp than the one just from our last influence study. Why would you want to do one of these though? I do include a NACE standard below. This probably is a newer version of this study. This is the one that I had on hand. But also the reason that these studies are performed are not only because you can have accelerated corrosion on a site if you have interference, but also it's the best practice and standard to identify and mitigate interference. That's why I wanted to include that standard there. If you are known to have interference affected by either your system or another system, you should know where it is and how to mitigate it. Otherwise, it could be auditable. So just kind of talking, that was a brief overview of I&I studies. So I talked a little bit about these in that brief overview, but there's some sources of influence and sources of interference that are pretty common across the board. And you probably hear about these in other ways, not specifically about influence and interference studies, but they come up pretty often in these specific type of studies. So in an influence study, you're really looking at potentially interruptible setting or items for your that influence your CP system. So, excuse me, your own rectifiers on your own pipeline, or if you have a neighboring pipeline from a foreign operator, if you have shared systems, so you have bonds, these will influence your CP system. So these are, and they're also usually interruptible. So these are things that are within our control that we can use to look at and understand the influence on our CP system. Versus with an interference study, these are things that are a little bit more difficult to interrupt and identify. So these are things like dynamic stray current. So a DC transit line, if your pipeline is next to a DC transit system, if you're near a mine, near a welding shop, or most commonly, more as it comes up more and more frequently in our industry, high voltage AC power lines. Again, like I said earlier, these corridors are pretty crowded. There's not a whole lot of new land to lay pipeline. So we're having to share a lot of these corridors with power operators. So we're having to share, and then whatever they do interferes with what our CP systems look like. And then lastly, for those that are in the north or far south of the globe, our telluric currents are also a very common source of interference that have to be found. And they're usually performed and found through an I&I study. So I've given through a lot of reasons why these exist, common sources, but really the biggest reason why you want to perform one of these surveys is you're going to want to ensure you're still in regulatory compliance. Because you may have unexplained CP system issues or corrosion in an area that you're not really thinking about or not paying attention to, that if you go into an audit, you're going to be asked about. And if you don't have anything to back this up, you're going to be in a lot of trouble. I have an example on the right side here. So my test station, saying that when I have my CP system is on, my test station reads negative 910 millivolts. So I'm within the NACE, within the PHMSA criteria. I'm within compliance, but I'm not aware that there's a foreign rectifier from my neighboring CP system that affects my pipeline, and it's providing me 200 millivolts of extra current that I wasn't aware of. So whenever that foreign operator interrupts their pipeline, my on reading is now actually negative 710 millivolts. So I'm actually not in compliance. I just happened to be in compliance when I looked at my asset. So this is a very common thing that happens across the board, especially as we've done more and more research into understanding interference and how all these systems next to each other actually influence each other. So kind of the goals of actually performing an I&I survey, you really want to understand where are the potential influence or interference sources. You really want to make sure you have a plan of how to mitigate these sources. If you've been able to find them through doing a test and you know where they are, you'll be able to make mitigations that will actually protect your assets longer than just allowing them to perform as expected or as you think they're going to perform, and then slowly start corroding and in an accelerated way. And also, of course, the last really important item about performing an I&I survey and an outcome that you're going to have is you're going to have documentation. If you have documentation that you've performed this study, you have identified interference and you've mitigated that interference, that will be that will go over well in if you have a situation when you are audited and or you want to maintain your compliance ecosystem, especially in PCS. This way, it's all documented, and you have a auditable, traceable record. so that this can be reviewed with others. And if y'all have questions, feel free to throw them in the chat as we go as well. I have a section for Q&A at the end, but the way with going with time, I may just start answering them as we go. Just wanted to throw that one out there. So we've kind of gone over what are INI surveys, and then now we'll go over some of the best practices and some methods for actually performing these surveys. So I'm kind of curious. I don't remember if I had a poll set up here, but I'm kind of curious, has anyone had to perform one of these in their past or very recently? I'm just kind of curious. You can feel free to put it in the chat as we go. Because I'd be curious to hear if this is becoming more and more common with a lot of our users. But what I wanted to talk about real quick is just there is a pretty solid testing process for performing an INI survey. So I'm not going to go through all of this directly for the sake of time, but I want to leave this up on the screen to show that it may seem daunting and it may seem like where do I even start? But it's pretty manageable when we get it into a real simple flow chart like this. Um, so really, how does this start out is you're going to want to identify an area that you want to study. So usually this means I ran a pig and I found a large amount of metal loss in a certain area, or I performed my periodic and annual survey. My measurements were off by several hundred millivolts that where I wasn't expecting or outside of criteria due to this. Um, so you may see like my measurements are pretty wacky, concerning. There's something I need to investigate. It also may be where once you identify I have a weird measurement, you may say, how close am I to my neighbors? Do I have a shared system? Am I bonded to somebody that I wasn't aware of or not documented well, or I just forgot about? And then finally, too, is my environment kind of volatile? That sounds really harsh, but you may think, what is my soil resistivity changing every season? Is my pH changing? Was there a landslide? Was there an inclement weather situation? There's a lot of items that go into this that would help you kind of identify where you want to start. And I do want to say, once you find your area that you want to start with, everyone's favorite step is next, which is having to coordinate with other people. So just putting it like this, a really successful INI survey, you cannot be completed without collaborating and contacting your neighbors, especially if you have a shared corridor like this. You're going to want to call your neighbor, call your fellow operator that's in the same corridor, or even your own technicians if you have multiple technicians in an area. And you're going to want to identify the pipelines, facilities, and other operators that you're going to have to bring into this survey with you. As well as, after talking with them, getting an agreement between all of you to actually begin this test. That's going to be probably the most important piece of this. That you can have all the technology in the world, but if you don't have the buy-in of your other operator, your INI survey is not going to be successful. And then you're also going to want to make sure you have the right tools and equipment ready for your survey. So I call out 3 specific items here, but looking at portable current interrupters, I call out the Micromax specifically. This is a very common use case for our Micromax current interrupters, and I'll go into a little bit more detail later on about this. Same with remote monitoring units. If you have access to bullhorn remote monitors, this will also vastly speed up your INI survey. And then finally, having a data collection device capable of capturing waveforms. And the photo here, Lawn Duke has our favorite Lawn Duke has an Allegro field computer, but we also use the PCS field data collector tablet as a very common way to capture a waveform like this. And lastly, it kind of all goes together, and you coordinate with your neighbors and utilizing bullhorn remote monitors, Micromax current interrupters. You have to coordinate and begin an interruption cycle, a staggered interruption cycle to begin capturing your INI data. So you're going to want to identify the various assets that you want to, I say assets, but really current sources. So in this case, rectifiers that you're going to want to interrupt and find out how they are influencing each other. You're going to want to begin interrupting these one by one in targeted groups with all of them at once and then staggering mode from there. Thankfully, we'll go into a little bit of detail of this on our products. All of the Micromax and Bullhorn products are going to include a mode called interference mode, and this allows them to sync with each other and perform this type of staggered interruptions cycle. So last thing I talk about before we jump into more of the tools used to perform the studies are manual interruption testing and versus the group synced interruption. So you heard me talk about using Bullhorn and Micromax to do synchronized interruption surveys for INI. This is now probably the most common way to perform an INI survey. In the past, I'd be curious to know in the comments if anyone's done an INI this way in the past, but having to do manual interruption tests. So this is where your best tool is a walkie-talkie or a cell phone, and you're at one rectifier cycling it at the cycle that you want it to be cycled at manually, and you have another technician at a test station trying to just looking at his measurements, trying to understand where the interference may be. That's probably not nearly as common anymore, especially in this day and age with Micromaxes, Bullhorns, and other tools being so common and available. But group synced interruption is definitely the way to go. This way you'll be able to synchronize and interrupt almost all of your rectifiers in one go, and then be able to gather test point data very easily at your site with PCS Field Data Collector. And it makes getting that data way more reliable and manageable than having to do it manually on a piece of paper. So after we put it all together, again, I really want to highlight this. You're going to want to make sure you set your interruption cycle in that isolated and staggered cycle. Using the Bullhorn remote monitors as well as Micromax current interrupters, you'll want to set this up in the interference mode. I have an example of this later on in our presentation. For the sake of time, I'll show you this is what it looks like. So this is just an Excel spreadsheet showing how these units are set up. But this is another good look alongside that animation of how this interruption cycle works. All of your units will start in the off mode, and then they'll go on. And then after that, say you're doing a 3 on. This is a 3 on, 1.5 off cycle for this one here. You're going to stagger each rectifier throughout the interruption cycle. This is for a total cycle of a minute for this one. So kind of talking about synchronized waveform capture, I want to talk about Bullhorn and especially why it's important to use a GPS synchronized tool to capture your influence and interference survey data. When you're not synced, your data is going to be bad. That's just kind of the blunt look at it. This is an example in PCS Field Data Collector of us capturing a waveform this was on a test point that actually had the interrupters set on there for 2 separate cycles. They weren't synced with each other, so we have a 3 on, 1 off on one of those interrupters. That second interrupter was set at the same schedule, but not synced. So here you have a really wacky waveform, and you're not going to get accurate off data or on data. So if you're trying to perform an INI survey like this, you might as well stop. You're not going to get good data out of this. And so that's really where utilizing Bullhorn and Micromax come in handy, since they both have this mode called interference mode, which allows you to coordinate staggered interruption with up to 99 other units, so other rectifiers and other interrupters, and they coordinate with Bullhorn and portable interrupters due to them using the GPS clock and GPS sync. And I plan to show how easy that is in Bullhorn Web, but I know for the sake of time, I may hold off on that. If we have time, I'll bring it up at the end of the presentation. Oops, here we go. And lastly, kind of what I talked about earlier about having a tool to collect the data, you're going to want to use a DVM or tool that with over a 5-minute window to capture a waveform. I say FTC, of course, because FTC, we do this out of the box where in our DVM application, as long as you set that window to 5 minutes and be able to capture a waveform with timestamps over that course of the entire 5 minutes. After capturing this waveform, you can then be able to take that wave print and upload it into Survey Manager for easy analysis. So by using all of these ecosystem of tools, you're able to digitize this data, capture it remotely, and then send it into our software to be able to be analyzed. It's a whole lot easier than trying to port all this data into an Excel file and turn that into a pivot graph and try to analyze it that way. So real briefly, for the sake of time, I'm going to speed through this, but we've got a real world example here. This is basically just taking everything we've talked about. So using what are INI surveys, using specific tools to set up this survey correctly, and then capture that data with the PCS field data collector application and putting it into real life. So in this case, we had a single pipeline with 11 sources of impressed current. So we had 11 rectifiers in this study and 3 separate test stations. And then what we did in this example, using bullhorn remote monitors and using Micromax current interrupters, we were able to set up all of these 11 assets to be interrupted in just under an hour and perform our interrupted survey at across all 11 assets. So this is the same interruption cycle from that Excel sheet I had earlier in the presentation. So following our process for doing an INI survey, we had all of our assets off at the beginning, then all of them on for 9 seconds, and then began our staggered interruption cycle, where cycle one, the first cycle is the first asset, our first power source here being interrupted out of 11, the second one, third, and fourth, etc. And as you see in that waveform, after we captured it, and we're able to label which assets were affecting which, you can see which areas had the most IR drop and the most voltage change based on interruption. And this was at the second test station. And at our third test station, this is the exact same cycle, but at the second test station, or the third test station, excuse me, you'll be able to see where that voltage impact is. And this will help you identify really which power source is actually affecting your CP system. So you'll see a trend here on cycle 2. It wasn't as bad at test station 2, but at test station 3, it's increased dramatically. So this way you'll be able to tell, oh, my rectifier, that third rectifier is affecting test station 3, that area, however many miles that was, that's affecting this area more than others. So I probably need to adjust this CP system, adjust that rectifier. So kind of the key takeaways from this was all done in an hour by one technician. I don't know exactly versus in the past having to get multiple technicians together. This could easily take a full day of setting up portable interrupters and doing this manually versus using bullhorn remote monitors and other tools to do this within an hour. I mean, that's pretty amazing when you think about it. And then we're able to easily identify the sources of influence by using Field Data Collector and Survey Manager. Being able to actually upload that data into our cloud environment and overlay it across each other, understand very easily using these tools which asset is which power source is affecting me where. It made it a whole lot easier to identify how I'm being influenced and where we can make mitigations versus before of having a notepad or having another Excel sheet and trying to piece together how everything works. So that's actually, I know I got 1 minute. Wow.